Hello, everyone, and welcome to Building SaaS on AWS, the AWS SaaS Factory show for SaaS builders here on Twitch. My name is Anthony McClure, and I am a solutions architect with the AWS SaaS Factory and your host for today's show. If you are currently a builder of SaaS solutions or are even just getting started learning how to design, develop, and deploy solutions into a multi tenant or SaaS environment, then this is the show for you. As with every episode, we like to bring on SaaS related experts that can dive deep into the various topics of SaaS and take you along with us for that journey. Today's show, of course, is no exception to this, as I have with me two other AWS employees that are good colleagues of mine, starting out with Farouk Ashraf and also Ravi Yadav. Farouk and Ravi, welcome both of you to the show. Farouk, you're actually a veteran of the show. You've been on the show a couple of different times in the past, but maybe you could go ahead and introduce yourself to the audience.
Yeah, thanks, Anthony, for inviting us to the show. Uh, a quick introduction. I am a senior solutions architect at AWS. I'm supporting customers in the ISV space. And I am associated closely with the SaaS Factory team, as a lot of my colleagues, have seen us before working together. And of late, I have been exploring common grounds between SaaS and generative AI, and that's what brings us together.
Well, again, welcome. Always great to have you with us, Farouk. And Ravi, you're new to the show, but welcome as well. Perhaps you'd like to introduce yourself too.
Yeah, thanks for having me here. So I lead our containers go-to-market for our ISV and digital native customers. Partner a lot together with Farouk as we work with our ISV accounts and our awesome SaaS Factory team.
Well, again, welcome to you as well, Ravi, and a great big welcome to our audience out there on Twitch that are joining us live here today. It is always great to have you with us. And remember, if you do have any questions for our guests today or about the topic that we're discussing, please feel free to put those questions into the chat in Twitch, and we will do our best to try and answer those as we get time to do so. And while you're there, be sure to say hello to our great moderator, Bill Tarr, who is in chat with us again today. So, with that being said, let's go ahead and get started with our topic of the day, which is actually a very interesting one, I think, to a great deal of our customers of AWS and throughout the greater zeitgeist as it may be, and that is talking about generative AI, as Farouk mentioned a few moments ago. Specifically, we're going to be talking about how you can utilize generative AI and services that AWS provides to create multi-tenant based chatbots. But now, generative AI is a bit of a new concept, I think, to a lot of people. Certainly, it's getting a lot of press today, but may not know exactly what that is. And maybe we should start there. So, Ravi, can you give us a little bit of an introduction on what exactly generative AI is?
Yeah, absolutely. So before generative AI, one of the things I'll call out is working with our customers and even throughout the industry. One thing we've all seen is that machine learning itself is going through an inflection point, right? Uh, it's primarily driven by a few things. Now, the compute capacity we've seen is increasing. We've seen the data sizes to be growing, and the model themselves are becoming more and more sophisticated, both in terms of the architecture of the machine learning models as well as the use cases that they can support. So with that, generative AI is the type of AI that can create new content and ideas, right? So it includes things like conversations, stories, images, videos, music, etc. And like all AI, generative AI is powered by ML models. So these are your large models that are pre-trained on vast corpus of data, right? And they're commonly
Hmm.
referred to as foundation models.
I see. And so when we're talking about this new type of machine learning, this generative AI, and the fact that it can generate content the way that it does, what are some of the use cases or how are customers actually utilizing this?
Perfect. Yeah. So as these models become more and more sophisticated, right? They're able to process a lot of data. They're able to process a lot of unstructured data, and we started to see a whole bunch of different use cases. So It's things like code generation, image generation, music generation, video generation. So there's definitely been a huge surge of the use cases around the generative AI space itself, right? And when it comes to choosing the right architecture, there are considerations, both in terms of performance requirement, the cost requirements, latency requirements based on the use case, and so on and so forth, right? But there's a whole bunch of use cases that are being explored in the space.
I see, and of course, based on the topic of this particular show, we're going to be focusing in on chatbots. I assume, is that correct?
Absolutely.
Very good. So, moving forward then into specifically concepts around generative AI and building out something like a chat bot. Again, related to the title of our show today, it looks like we're looking at using containers and Amazon EKS for this. Is there any particular reason why containers are a good solution for building generative AI solutions? And could we use something different? Could we go serverless, for instance, with Lambda?
Yeah, absolutely. We could use a whole bunch of underlying infrastructure to be able to build chatbots, right? So we'll talk about Kubernetes and EKS and how we build the architecture there. But you can definitely build out the chatbot architecture using our serverless technologies as well, right? Now,
Okay.
on containers specifically, one thing is there that once customers have made a choice of using containers, based on the advantages that it provides, Kubernetes is usually the natural evolution for orchestrating those containers,
Mm.
along with the tooling that exists for Kubernetes. And when it comes to AWS, running Kubernetes on AWS, EKS is the best way to run Kubernetes because of the managed control plane that we provide. So with that, a lot of the heavy lifting that customers will need to do, a lot of that gets put onto the AWS, and customers don't need to have to worry about the underlying infrastructure, but only on developing their applications.
I see. And you are, as you mentioned, an EKS container specialist, right? So if our chat has any questions about EKS, you're the guy to go to.
Sure thing.
Great.
Yeah, we should chat
So
about that as well, right? So why EKS specifically for AI/ML,
sure.
right? We talked about
Okay.
containers, but EKS addresses several challenges, both in training and in inference. So it's things like your scaling challenges, things like infrastructure failures, multi-tenancy, and cost, right? EKS addresses each of these challenges directly using the different native Kubernetes capabilities, things like automated scaling, uh, increased resiliency, and workload isolation as well. And we look at each of these elements. So, for instance, if you look at automated scaling, it's sort of the inherent functionality within Kubernetes that comes out of
Mhm.
the box, right? So you can scale based on the parameters that are configurable, and you can define parameters under which Kubernetes would need to scale and provide your workloads more resources. And on top of that, EKS provides auto scaling loops, so which makes it easy for you to orchestrate bringing up nodes as well as adding those nodes to your EKS cluster as well. If you want to look, sorry, go ahead.
No, I was also just going to mention that, of course, from the SaaS factory's perspective, we believe that EKS is obviously a great solution, especially when producing containerized based uh, SaaS multi-tenant applications. We have built an entire architecture around that, our EKS reference architecture, and perhaps Bill can put a link to that into the chat as well. So if you're out there perhaps thinking about building a SaaS solution around containers, I would highly recommend looking at that reference solution. But secondarily to that too, we're going to be talking about a lot of different technology here today to ultimately build out this chatbot that EKS provides, EKS kind of being the basis for it. But given the complexity of what we're looking at here today, is there a place that our customers can start from? I think you guys have been doing some work, right, as far as getting code that's out there and available for our audience.
Yeah, we have both the code as well as we've now also published a blog post, and maybe in a couple of slides we'll pop up the QR codes for that as well.
Perfect.
And maybe Bill, if you're there, you have the links, you can post that in the chat as well for the folks on the stream here.
Yeah,
Perfect.
I would like to just also mention we also have an architecture pattern site, which is data on EKS. I guess Ravi can talk more about that. We have quite a lot of patterns evolve over recent time. So I think that's a great reference point too.
Awesome. Yeah, great. Perfect. So, in addition to EKS, well, actually, I think I stopped you in the middle of a thought that you had, Ravi, that you were going to continue on with. Sorry, go ahead.
No, sure. So we talked about like the auto scaling aspects of EKS,
Right.
right? But there's obviously other things because of which a lot of customers have already standardized on Kubernetes, can leverage the functionalities, tooling, features within Kubernetes EKS to be able to build out different use cases. So apart from automated scaling, it's the resiliency aspect of it, right? So it's again sort of the native sort of functionality where you get the where you have a desired state configured for your cluster, and Kubernetes under the hood has controllers, for instance, that ensures that it can constantly monitor your infrastructure and keeps your infrastructure up to date to the desired state that you had configured. Right.
Excellent.
Workload isolation is something because of which Kubernetes addresses a lot of those challenges, and addresses Kubernetes addresses the multi-tenancy challenges as well. One of the things we've seen many of our customers do is wanting to be able to share a cluster across different organizational units, teams, business units, etc., within their organization, right? So Kubernetes again provides the workload isolation through things like namespaces, for instance, which can be
Hmm.
used to share a cluster across multiple teams and used for multiple use cases as well.
Yep.
And finally, Kubernetes is a cost-effective solution, right? So even EKS offers you the ability to pick and choose which type of EC2 instance you want to use. So whether that's EC2 Spot or any type of EC2 instance, as well as the processors you want to use from AWS that provides a balance of different kind of things like high throughput, low latency, while you look at meeting your budget constraints.
Yeah, the flexibility there, I think, is a key core component to not just Kubernetes, but specifically EKS on AWS for deploying Kubernetes-based containers. So, it makes a lot of great sense then why you would use that as far as building out AI/ML solution. Um, Also, what about specifically around what we're talking about here today? Uh, there's a lot of technologies that are listed as far as the title. LangChain, Amazon Bedrock, which of course is very new. This concept of RAG, and getting into how this all kind of comes together related to generative AI. Can you talk a bit
Yeah.
about that as well?
Sure, yeah, absolutely. We should absolutely do that before we get into the architecture of building the chatbot. Uh, let's start with RAG, for instance, right? So RAG, or Retrieval Augmented Generation, it's a common pattern where a general purpose language model can be queried or is queried with a user question along with some additional contextual information that's extracted from different kinds of documents to be able to then generate uh, text based on the context of the data that you do have, right? So foundational models, for instance, are trained on the general domain corpus or general data sets, making them less effective for very specific type of tasks that you may have, right? So that's where you can use things like RAG to be able to retrieve data from outside the foundational model and augment your prompts by adding the relevant retrieve data into the context itself.
Interesting. Okay. So what about some of the other technologies that are related to this, and how would we utilize, RAG, for instance, to actually build out an architecture? And specifically, I think maybe a question here too is, all of this has a lot of moving parts to it. Whether we're talking about EKS, we're talking about RAG, we're talking about LangChain, all these different pieces. Uh, when we start to bring in multi-tenancy and SaaS into the mix as well, I assume that that adds additional challenges as well, right?
Yeah, great segue, Anthony, into how we pull these different technologies together, and you talk about the concept of chatbot and why is it so important. Uh, so just a quick overview of what some of the common use cases for chatbots are. They have been in use for quite some time, and they've been using uh, traditional ways of processing text coming in from user. But now with the rise of Gen AI, it has become there's been a rising interest in using Gen AI for chatbots, particularly for use cases such as customer support, Q&A of various sorts, simple things like billing inquiry, payments, refunds. So all these various types can be very easily handled by chatbots, and you do not need to have, for example, a human in the loop in these types of applications.
Do you feel, when we're talking about using generative AI specifically for chatbot capability, what does it feel different, or what is the response like different between maybe what somebody would traditionally think as a chatbot, or because chatbots have been around for a very long time? So, what does generative AI based responses look like, or is different from what a traditional chatbot would bring you?
Yeah, so one major difference is that traditionally the chatbots that we've seen, prior to Gen AI, have operated very much like the phone IVR systems, where you will be asked very canned questions and then the user responds to them, and based on
Select
that,
a number kind of thing.
yeah, very similar to that. Not exactly, but yeah, very similar to an IVR system, where
Right.
you have some canned questions and there are canned answers to those. Generative AI makes it a more sort of an organic conversation, a more natural conversation with the customer or end user. And especially with the multi-tenancy aspect here, uh, the capability of specializing that conversation or sort of contextualizing that information with tenant specific data makes it a very attractive option, and it
Hmm.
creates a more engaging customer experience.
Feels more like talking to an actual person than just necessarily a machine, right?
Correct, and I feel maybe the end users probably don't so much care about whether they're talking to a person or a
Mhm.
machine, but it's the engaging aspect of that conversation that makes it more attractive for organizations to adopt this kind of chatbots.
I think too the depth of content, right, that a Gen AI based chatbot can get access to, and therefore can retrieve and summarize or bring forth to the end users, probably quite a bit different as well, right?
Correct. Yeah. So as Ravi was just talking about RAG, right? So RAG actually means quite a lot of things. So it could mean internal data to the enterprise, the data that they may have specific to their tenants and customers. It could also mean retrieving data from the internet. So for example, if you're generating some information that needs weather data to be inserted, so it could reach out to a weather service and get that data in. Or if you're looking for some search results. So it could reach out to a search service like Google and retrieve data and feed it into that conversation as well.
Yeah, we have actually a question from our audience here, and Farouk, you might want to tackle this one real quickly. Considering I'm a newbie, where do I need to start with this topic to create a chat bot? I think is what we meant to say there, for a charity website.
Um, Again, so coming back to the concept of whether you need multi-tenancy or not, that is going to be essentially the starting point. And if you do need multi-tenancy, you do need to have some sort of connectivity to tenant-specific data and the
Mhm.
architecture that we discussed. You may start from our blog post. That may be a good place to start.
I think
And
Bill just put that into the chat for us. So thank you, Bill.
Yeah, great. And we also have some other great content from AWS for various types of chatbots and various types of chatbot applications. So I would definitely suggest exploring some of those recent blog posts that have come out.
Thank you for that question. So we were talking about then adding in multi-tenancy here, right? And multi-tenancy does add some additional complication as you were getting into, Farouk. So if you want to go ahead and continue from there.
Yeah, so before we go into that, I just wanted to kind of level set on some of the additional concepts that we're going to need going into the deeper discussion of how we put together this architecture. So one of the concepts is around foundation models. So we've been talking about generative AI. So generative AI is built on what are called large language models. These are the AI models that are pre-trained on vast amounts of data. and are adaptable to many tasks. So traditional AI ML models are focused on one specific task. They can do that task really well. Uh,
Mhm.
but this has evolved into models that can now do multiple tasks, and these tasks are based on unstructured data, as you were earlier mentioning. Traditional AI models are more focused on very structured data, where you have tables and tables of data, which they get trained on, and they're really great at doing that. But with the rise of large language models, the ability to process unstructured data, such as text files or text data, has increased significantly.
I see.
And so some of these foundation models, AWS offers a few of them through Amazon SageMaker, through a service within SageMaker called Jumpstart. And there are many of the open source models that are available, like Llama 2, Falcon, Flanty 5, GPTJ, and there are several others which are available. Some are open source, some are proprietary. And you can access them through SageMaker Jumpstart. Then we also recently launched a service called Amazon Bedrock, which offers several well-known models from very well-known AI organizations, AI companies, and these are available as API services. Rather than you having to manage the infrastructure, you just simply call the Bedrock API and get access to these pre-deployed models within your environment.
So that's it looks like a fairly large different selection of models here, which I think is one of the great things that AWS is offering. But one of the big questions that we see a lot from customers is, how do we choose a model, right? And I assume that they're all good at certain specific things, and yeah, as with everything, when it comes to building any sort of SaaS solution, the answer always starts with, well, it depends, right?
You're absolutely right. So it depends. In this case, means experimenting with a number of these models for your use case, and trying out, again, depending on what type of use case you have, whether you have a text based use case or image based use case and so on. You may want to try out different models and see which one works best for you. And even among these different companies, like Anthropic offers 3 different types of models. AI21 similarly offers 3 different types of models. So you may have to do a bit of experiment. And along with the experiment, I think there's another aspect of cost. So the bigger the model, the higher the cost. So that's a given.
Right.
So you may start experimenting with simpler models and go towards more complicated ones or bigger ones, or the other way around, start with the more complex ones and move towards the simpler ones, depending on, again, what your use case is and uh, how the output of the model satisfies your requirements.
That makes sense. And of course, with SageMaker Jumpstart, and with the capability of using API calls to call Bedrock, and both of these two tools can help with that process of experimentation, right? Trying to make it as
Yeah.
easy as possible to get access to all of these different models and to call them independently, and see how they perform based on the prompts or the queries that our users are creating.
Yeah, absolutely. And both of these services continue to evolve, and we continue to add newer and newer models on both of these. So I would definitely suggest for our viewers to explore these services and see what we offer.
Excellent.
Uh, Another couple of concepts, and then I promise I'll get into the architecture. But I thought it's important to get these across first.
There's a lot of foundation here with this new technology. Yeah.
Yes, absolutely. And we wanted to make sure that we cover most of the important aspects here, so that we don't leave areas which are kind of unclear. So another important aspect there is embeddings, which comes up quite a lot in any literature that you read, whether it's a blog post or any research article. It comes up pretty frequently. Embeddings basically are in data that is encoded into vectors. And vectors are concepts, I think they're from high school, I would say. I studied them in high school. So they are like lists of numbers. They are in multiple dimensions. You could have all the way from one dimension to thousands of dimensions. And essentially what these embeddings do is they they try to capture meaning as well as context into those vectors. And why we convert data into embeddings, or why we generate embeddings, simply because they help us search similar data in a very efficient manner. So if you have numbers, it's very easy to calculate which numbers are closer to which. So that's one of the major advantages of using embeddings in this specific context. And we use embeddings models that convert text into vectors. So, for example, on Amazon Bedrock, there's an embeddings model called Titan Embeddings that helps convert supplied text into vectors. You could make API calls and supply the text that you want to convert into embeddings, and it'll return back a vector of, I believe the current size is 1536 or 1536 numbers, a list of that many numbers, and that's your vector. And just a pictorial representation of how it would look like. So you supply a bunch of text. It could be continuous supply of text, or it could be just pieces of text, and each one gets translated into the series of numbers or a list of numbers that we call vector embeddings.
And just so that I understand then, Farouk, specifically the purpose behind this is to transform what is normal everyday text that we're familiar with into this format that can be used by the search algorithms to find things that are related. So that if you're asking about a specific concept or idea, it could find these documents or other texts that are related to that idea. Is that what we're looking at?
Exactly, yeah. So for example, think of concept like pen and pencil, right? So if you generate vectors for a pen and pencil, they would most likely be very close to each other because they are similar. They represent similar concepts. While if you generate embeddings for a car and aeroplane, probably they're not going to be very close to each other because they are fundamentally different concepts. And that's
both
what
transportation, but not in the same way.
Correct. Yeah, they are. They may be somewhat close, but not as pen and
Right.
pencil, right? So
That
because
makes
they
sense.
are. So that's what I meant when I said they try to capture meaning as well as context. So the context part is essentially it looks at the different words and sentences that you have in your text, and it tries to make sense of that context and how those words are used in that context specifically. So the word pen may be used in one context in one document, and in another document it may be used in another context. So it takes it takes all of that into account while generating those embeddings.
And so I assume then that this is used as part of the retrieval part of the retrieval augmented generation from RAG. Is that correct?
Absolutely. So that brings us to our next concept, which I promise is our last one, which is the vector databases. Right. So when you have all these tons of vector embeddings that you're generating, assuming that you have lots of documents in your environment or lots of data that you want to convert into vectors, you need somewhere to store them and be able to retrieve them efficiently. And that's what exactly vector databases do. They provide you storage and efficient retrieval of these vectors. They provide various algorithms for finding what is called a nearest neighbor in n-dimensional space. So you have, let's say, two vectors. You want to find out how far they are from each other, like pen and pencil, or let's say car and an aeroplane. So the vector database helps you find that distance between those vectors in a very efficient manner and using various algorithms. There are several algorithms that help you find distances. And common ones are like, there's one called Manhattan distance, there's another one called cosine distance, and there are so many others. These are the common ones that I just wanted to mention the names because you may come across them in literature. So there are several algorithms, and there is continuous evolution in that space as well. Right, and the biggest thing that vector databases offer you is that they help you operationalize these embedding models. So thinking of these large amounts of vectors in an enterprise environment, you definitely need scalability, fault tolerance, some sort of access control, indexing and fast querying of this data that goes into the vector databases. So that's what essentially these databases help you achieve. And some of the offerings, just wanted to mention from AWS, include Aurora Postgres SQL with pgvector, and Amazon OpenSearch. These are two offerings that AWS has today, and there are others as well from our partners like Pinecone and so on.
So we did get a question from the audience related to this. And it's actually kind of a two-part question. It started out with, how are embeddings useful in B2B applications versus just looking up an exact value in a database? And then, he rephrased to say as well, why use a vector database in this versus just a regular relational database or some other lookup?
Yeah, great question. So regular databases or relational databases, they help you find exact data. So if your query does not contain the exact data that's stored on your database, it may not even find it. What vector databases do is they help you find similar data, not exactly the same. So it'll find the distance, as we mentioned, between the two vectors. So essentially, when you enter a query, it's going to calculate a vector of that query, and it's going to find what are the nearest neighbors of that vector within my database. And then it's going to return a few of them, depending on how many you ask. You could go all the way from 1 to, I guess there's some upper limit, 5, 10, as you need, depending on your use case. You could ask the database to return that many nearest neighbors to your query. And then, that's the key difference between a vector database and a typical relational database or other sorts of databases.
I have another question too, maybe kind of a follow-up to this, but we see how does chunking work with embeddings, and also would you classify Elasticsearch as a vector database as well?
So yes, that's again a great question. So chunking is an important aspect because most of the text models that we have, the large language models where you're looking to generate text, they have limits on how much data you can send to them as input. So you may want to chunk your data before you actually send it to the model. And if you have like huge amounts of large PDF files where you have very long PDFs, hundreds of pages, they may not fit into what is called the context window of your request to the model. So you may have to chunk them. And we'll see an example of that. And typically in our architecture, we're using LangChain for doing that. So LangChain provides some capability to do chunking of your data. And then you can create embeddings for those chunks and then, essentially search across all those embeddings that are there. To your second question on Elasticsearch, so Amazon OpenSearch is I would say it's a fork from Elasticsearch. Yeah. So originally we have Elasticsearch as well, but I guess at a certain point we forked it to OpenSearch, and then that's what we're building our vector databases on. I'm not sure if the Elastic offering of Elasticsearch has vector databases yet, but the OpenSearch does. It has started supporting vector embeddings.
Well, I think the audience is getting a little bit itchy here to see your architecture and that we built for this. So, Farouk, if we want to switch over to that, while you're doing that, I can also bring up here just real quickly. We do have these two QR codes to the blog post, and also ultimately to the GitHub page that Farouk's going to be showing us here in a few moments, to where the code is that you can actually take a look at this yourself. But we'll come back to it if you don't get it right now or don't screenshot this right at this moment. But just to let everybody know, so I'll bring it back up here in a few minutes as well. But Farouk, I do want to say as well, real quickly before we jump back over to you, that this is Building SaaS on AWS, and I am joined today by Farouk Ashraf and Ravi Yadav that are talking to us about building a multi-tenant chatbot capability using generative AI and other AWS services and techniques. So Farouk, back to you here about the architecture.
Thanks for posting that blog post QR code there. That's, I think, users can probably look at that while we're talking about it. It's got a lot more information than we are presenting. So yeah, great link there. So I'll just quickly go over the solution in a very high level manner, not digging into the details. All the details are out in the blog post. So we're building on top of Amazon EKS, as we've been discussing from the beginning of our show. And within Amazon EKS, we have an ingress controller. In our specific case, we're using Istio, as we have been using on several of our other architecture patterns as well, for various reasons. And we describe, a lot of the details in our blog post on why we chose this architecture. But yes, there are many other options to use as ingress controllers.
Nginx and others. Yeah.
Absolutely, yes. There are many options, and depending on your use case, on your environment, what you use currently in your environment, you could opt for any of those.
Right.
So and within EKS, we deploy these different tenants that we have, and each of those tenants, as they send their requests, they are intercepted by the ingress controller. The ingress controller redirects the request to an identity provider, which could be different for each tenant. Right. So as tenants come in, they may or may not have been authenticated and authorized. So the ingress controller basically looks at what in SaaS parlance is very common, a JWT token, which is a sort of authentication and context management mechanism. And if there isn't a JWT token in the request, it'll redirect it to the identity provider and get the user authenticated. So once that is in, the request goes to the specific tenant's deployment in the backend. Those applications, they are identically running applications for each tenant. They have access to a vector database, and we'll go into the details of what type of vector database we use here. You could have each tenant use a different vector database. You could share a vector database. Again, it's the concepts of multi-tenancy are all applicable across various of these services that we make use of. And also, each of these application deployments, they are communicating with our foundation models, right? And there are two foundation models we will be using. One is the vector embeddings model, and the other is the text model. And we'll get into more details of these as we go along.
So just looking at isolation, like it's a bit of a hybrid model in this case then, right? Where we have, or it appears to be more of a silo-based model as far as the tenants with their chat app, but then sharing services like database and foundation models going through Bedrock.
So in the picture, it looks like a silo sort of model, but you could have, all the various deployment models, that we discuss typically in a SaaS context. All those are equally applicable. It appears in the picture as if they are silo, but they can be pooled as well.
Could be pooled as well. Okay,
exactly.
Great.
Yeah. Just to keep things simple for our discussion, we decided to go this way. But yeah, absolutely, all those SaaS concepts are equally applicable.
Great. Okay.
Yep. So let's go into the another important piece, which is data ingestion, and this is where the chunking and all those pieces come together. So imagine your raw data is sitting in an S3 bucket. You have your embeddings model, and you have your vector database, and you basically use an ingestion process to read the data, generate embeddings, and then store those embeddings into your vector database. So this is a process that kind of happens before you actually run your query to get your data into the vector database. So your chatbot or your various processes associated with the chatbot are able to search through this data.
Because that raw data. And that raw data would be like your domain specific data or the data that's specific to the tenant in this case?
Correct. Yeah. So in our case, these are just simply, text files. I'll talk about those. There's FAQ data that I've ingested, the public FAQ for some of the AWS services. But this raw data could be, in any format.
Could be
It could,
employee handbooks or policies and
yeah,
procedures manuals or
yeah,
anything like that.
PDF files, Excel
Yeah,
sheets. Could be any of those pieces of unstructured data. And we're talking specifically about unstructured data in the context of RAG. But as we have been saying, RAG could be structured or unstructured. You could even query a relational database to get data from there.
sure.
But we're focusing more on unstructured data here. All right, so getting into the solution components, and this is where we'll talk about some of the pieces that you mentioned earlier, like LangChain. So the chatbot is built on a framework called Streamlit that has become lately very popular with generative AI applications that helps build very engaging chat interfaces very quickly. So that
Yeah.
is one of
I
the
think all of
advantages.
us are back end engineers, right?
Yeah,
I'm certainly not a front end engineer at this point.
correct. So you don't have to deal with complex, React or Angular or any of that. It helps you build a Python-based interface and very simple. In a few lines of code, you could generate a fairly decent interface and very quickly. The second piece here is what I call a RAG API. That's not a standard. That's not a standard terminology. That's the terminology that we use. So this is another container that we deploy as we deploy our application, and this is based on Fast API, another framework that has become very popular lately. It helps run REST APIs that are actually going to call LangChain for LLM orchestration. The third piece is FACE, which is Facebook AI Similarity Search. It is an in-memory vector database index. So talking about vector databases, we talked about OpenSearch, we talked about PG Vector. This is a kind of small footprint vector database which can be loaded into your container's memory. It does not have an external footprint. It sits within your application's compute environment, and we chose to go with this is for various reasons. One is because it has a small footprint. It's for demo application. This serves the purpose. You do not have to set up a large complex infrastructure just for the vector database, but it is equally possible to use other types of vector databases here.
Of course.
And the last but not the least, very significant piece of the architecture is LangChain, which has also picked up recently. With the launch of various generative AI services, LangChain has become one of the most popular frameworks for integrating various large language models and orchestrating the tasks that are performed by those models. Particularly like chat history management and prompt engineering. There are other solutions as well. So there is another framework, which is Llama Index, that has been upcoming, and it seems to be getting very popular. But LangChain seems to be relatively more commonly used by practitioners in the area. All right, we'll just go into the flow of chat. We will see a bit of demo as well as we progress a little bit further. So when the chat starts, we see a tenant starting a session. So a user request comes in, intercepted by our ingress controller, which is redirected to the identity provider. The user signs in, and it comes back with the necessary authorization token. And it lands into the tenant's namespace within Kubernetes environment. And here we have our containers deployed. So we have the chatbot container where the request lands, and behind the chatbot, we have our RAG API or LangChain running, and also the face index, which is running on the compute. I see it as a separate component, but it's essentially running within your container compute. So what the chatbot container does is it creates a session ID for the user. And for that, we use a DynamoDB table, another great Amazon service for NoSQL types of use cases. And some of these components are natively integrated with DynamoDB. The second piece, which is LangChain or RAG API in our case, it is going to save and retrieve chat history in a DynamoDB table, and that chat history is associated with the session ID that we created earlier. So the two are sort of linked to each other.
And that's a very important concept to mention as far as specifically Amazon Bedrock services. But we do not store that history or the information that goes back and forth to the models. So it's important to keep that chat history if you want to use that context to continue having a contextual based chat. Correct?
Correct. Yeah. So chat history has many use cases. So typically, downstream applications, like if you want to do sentiment analysis of based off of the chat session that a user had, or if there is a need to contact the customer back and talk to them on the phone. So there could be many different downstream use cases for which chat history may be useful. It's not a requirement, but typically companies would take a chat history and analyze it further and see if there's a need to communicate with the customer further on their conversation.
Makes sense.
So while it does, it saves and retrieves the history, and then what it does is it puts together all the information. So the request that's coming from the user, and it brings the chat history, and it sends all of that into the language model to get a response. So this is kind of the high level. We'll go a little bit deeper into that and see how these various things are going to work.
And real quickly, Cloud Exploring asked the question. I think we talked about this very early on, but could Lambda and API Gateway replace Fast API? And I think the answer is absolutely, right. Any portion of this could use other sorts of AWS technologies, whether that's on the compute side or on the API side.
You're absolutely right, and we do have architecture patterns supporting that. We do have some blog posts out there as well that explain how to use API Gateway and Lambda for similar use cases. So yeah, absolutely. So in our case here, we see the chatbot container. The request comes in. Let's say the user says, "What are foundation models?" It goes and creates the session ID. It gets, if the session ID is already there, or it's created. So it's basically a UUID that is either created or retrieved from the DynamoDB table. Then that user input and the session ID are sent to the backend, what I call the RAG API or the LangChain, which retrieves the chat history from another table. It puts the user input and the history together and generates an embedding. You get what is called, in my case, is specifically question embedding. It retrieves similar documents based on the embedding that has been generated, and those are retrieved from our face memory index. And all of that is sent together to our large language model, which in our case is Claude Instant and is offered as part of Amazon Bedrock. And Claude Instant comes back with an output, and that output is sent back to the user's UI. And a lot of these pieces, which are numbered here, 4, 5, 6, and 7, are handled by LangChain. So that helps you orchestrate all of that, and we'll probably get to the point where we can see the code a little bit and see how within a few lines of code you can handle all of this communication.
So LangChain is really kind of acting as the glue and organizing the steps of doing all these processes together, or in the correct sequence.
Correct. Yeah, absolutely. And it's a powerful tool. It has a lot of features. There's another concept that is becoming very popular of agents, where you could, build chains of chains to do very sophisticated tasks. But yeah, that may be for another session in future, hopefully. All right. So last thing I just wanted to discuss is the architecture of the pod, and pod being the Kubernetes concept.
Kubernetes pod.
Exactly. So how that is deployed so what we do is we create an AWS IAM role for authorizing access to some of these services, like the S3 bucket and the DynamoDB table and so on. And that IAM role has those permissions. We deploy our namespace, within which we deploy a service account, a Kubernetes service account, and that Kubernetes service account is mapped to the IAM role that we created, so that service account is able to access those resources that are created on AWS. And in AWS parlance, it's called IAM role for service account. So it's kind of a glue between the two together. And within the namespace, we deploy our pod, which has the two containers, the chatbot container and the RAG API. And that brings us to the end of our architecture discussion. I can jump into a quick demo.
Yeah, we still have about 5 minutes. Yeah, if we want to actually show off the fruits of this labor here. While you're bringing that up, Farouk, I have a question that has come in, and the question is, really related to Titan embeddings, fast Claude. We're talking about it from a multi-tenant perspective. Are these shared services right now, or are they really broken out multi-tenant? In the current architecture.
So at the moment they are shared. So in fact, within your AWS account, these are shared services. What is multi-tenant is more the RAG part, where you're pulling data from tenant-specific, databases or sources of data, and then sending them to these embeddings models. So Face is multi-tenant. It is deployed per tenant, as you would deploy any database in a multi-tenant fashion. It could be silo or pool and so on. But since Face is deployed on the container, on the compute itself, so it currently, by definition, it is in a silo mode. But yeah, you could if you have multiple tenants on the same container, it'll be in a pool mode. But yeah, embeddings and the Claude, they are shared at the moment. Yeah, I mean, and there could be architectures where you could deploy separate models for separate tenants, and that would take you into the realm of SageMaker Jumpstart, which is which will have a bigger footprint compared to what we are talking about.
Thank you very much. And so while you're bringing up your demo here, I did just bring up the blog post QR code one more time for everybody. If you haven't yet gotten access to it, please feel free to grab that QR code here. And once Fruit gets his other screen shared, I will bring that up. Looks like we're good to go. Okay, so
yeah, I guess
back to you, Farouk.
Sure. Yeah. It seems I have been timed out of my session, but yeah, just quickly logging in. So here we're demonstrating two tenants. One is tenant A and the other one is tenant B for obvious reasons. And you can see how we distinguish those. There is a tenant ID here as well as a user ID belonging to that tenant. And the same here for tenant B. So everything else is exactly the same. This is contextual data that is coming in once the user logs in. This data is extracted from their token. And what we have done is for tenant A, we're using this data, this public FAQ as a RAG source. And for tenant B, we're using Amazon EMR FAQs, just for demonstration
just to
purposes,
have some data, right?
Just to have some fun around these textual pieces of information, and to distinguish between the two. Yeah, I mean, you could take this and apply it to any type of data and extract all sorts of PDFs and so on. So that's kind of the context. Just wanted to show also some of the DynamoDB tables here. So we have a sessions table for tenant A. As you can see, currently there's nothing in here. We also have a chat history for tenant A, which also currently doesn't have anything. And similarly for tenant B, we have the session and chat history. So what I'll do is I'll just quickly enter a question here for both of these and see how these respond and what happens to our backend databases. So here I ask a question: what are SageMaker Foundation models? So it comes back with an answer, which seems to be a reasonable answer. And it also provides you a source of the data. So as you can see, this is a CSV file that I created from the SageMaker FAQs, and I have it in my local data folder. And so it basically is providing me a source annotation as well. Similarly, for the second tenant, if I ask the question, what are some of the applications of Impala, which is a component of Hadoop, we should be able to get an answer here too. Yeah, so it does come back and show us some of the details of Impala, yeah, interactive query on large data sets. Yes, seems to be a reasonable answer. And again, it annotates the source as Amazon EMR FAQs.csv, which again sits on my local data folder.
Excellent. Well,
Yeah.
Farouk, I have to say, this hour has gone by so fast, and there was so much that we had to talk about. Sorry we weren't able to necessarily get into the code, but the code is out there and available, right? We put up the links to
Yep.
the GitHub.
Absolutely. So, yep.
That's the
Yeah,
last thing I would add there, right? So if you're looking to get started, check out the blog post, check out the code repository. We also have the data on EKS website. Maybe we can post a link here as well. Check that out for other data-enabled blueprints as well, right? So building data science platform, Jupyter Cloud, multi-tenant Jupyter platform, for instance, as well.
Absolutely. And thank you both so much for being here with us today and exploring this really fun and interesting, new and exciting technology, really, that's available to all of us. For all of you that have joined us here today, asking great questions, we really appreciate having you here as well. Hopefully, we'll have Farouk and on maybe for a fourth time in the future. And Ravi, certainly you have an invite to come back as well. Maybe we can dive in even deeper into this topic. But for all of you out there, you have been watching Building SaaS on AWS, and thank you. Have a great day. And in our next episode, we might just have a customer coming on that is going to expand upon this very topic and how they're actually using a lot of what Farouk and Ravi have been talking about today in a real world production environment. So we hope to see you next time. Thank you, everybody. Have a great day. Bye-bye.
Thanks, Annie.
Thank you.
Bye.